so here we are right now. We're going to do some short circuit welding. We have a few examples here of pour fit up or a gap. We have horizontal welding for a T-joint. We're going to make a couple welds, kind of talk a little bit about the different short circuit welds that we can perform. So we're going to be using our Multimatic 220 AC/DC. I'm going to start off with just a straight short circuit weld, kind of talk a little bit about the parameters, kind of what we're seeing and doing with those. So here we go. All right. So I performed the short circuit weld, kind of like we talked a little bit about it. We have a crackling sound, like crispy bacon sound making. My parameters were at 19.1 volts and 304 wire speed. So it's a little rounded to where I like. I want to maybe flatten it out a little bit. And a way we can do that is by applying more voltage or decreasing wire speed. I'm going to give it a little bit more voltage, and what voltage in relation to this is pressure. So what I'm going to do is I'm going to apply a little bit more pressure to the weld to help flatten it out. So here we go with that. All right, so what I did was I went up a 1.5 volt. I went up to 20.6. I left my wire feed the same. So here's kind of the result that we saw. So here's my first weld. If we look at that, it's got a little bit of a roundness or a crown on top there. So I wanted to flatten it out, so I increased my voltage, and that was kind of the outcome of that. Now, there's various things that you can do as well, not just adjusting voltage. You can actually include an inductance. A lot of machines have this, and it's only for short circuit transfer modes. So what it's doing is actually slowing down the time of the current going through, so the voltage pressure is on longer. Where you would use that is more of like your stainless steel applications to help, because stainless steel welding on there, it's kind of a rolled looking effect. And they use a tri-mix blend with a high helium content in there to kind of help give it more energy to wet out the puddle. But if you need a little bit more, you can introduce an inductance. All right, so now I got a couple examples here. We got something with a gap. So like mentioned in the last video, short circuit welding does really well with gap welding because that wire is coming into direct contact with the metal all the time at a very fast pace, about 120 times per second, which is fairly quick. And here I try to simulate a little bit of a pour fit up. It's kind of another gap here, but it's still something you have to work around when you're making your welds. So I'm going to apply some of this information here and leave my settings where they're at and see what our outcome will be. All right, as you can see here, I've left my settings the same here, and here's kind of our result. So we got just a little bit off track there, but I was trying to stay within that groove to make sure the weld is going to fill in there. It's a little high because I was more perpendicular to it to make sure I kept my weld puddle at a consistent heat. So if I were to angle it out a little too far, what would happen is my heat's going to be generated out in front, and it's going to start eating away. If I were to do more of a pull effect, I would have a little bit of a better result because I'm keeping the heat behind me into the weld puddle as I'm moving along, or keeping the front material cooler as I'm working my way across. So here's the one with the gap I threw out there. So the first one I made was just going straight across. I was moving just a hair too fast on certain spots of it. This one here, I introduced a weave. So the weave, I was kind of controlling my puddle as I worked back and forth to maintain a good weld puddle. If I look at the back side, you can see I kind of went through a little bit. That's just to show, hey, I made pretty good fusion all the way through for the most part. You can see by the heat affected zone, I have better results on the weave pattern because I have more heat as I'm touching each part of the weld. One thing I did want to note on the short circuit transfer, it always has a cold start, meaning at the very beginning of the weld, it's always going to have a roundness to it. And eventually, like you see in this one here, it eventually flattens out. It's always going to have a cold start. So next time we'll talk a little bit about the globular. We'll talk a little bit more how that start looks. Also with short circuit, you can do a little bit of out of positioning. So we can do, your vertical ups, you can do overhead. And it's just some modifications of changing your settings there. So next time, we're going to talk about globular. We'll see you then.